Hello guys, welcome back to my YouTube channel. My name is Adekoya Samuel, popularly known as Dr. Sammy. So on today's episode of PHY 102, we'll be treating electric field. So this course is for 100 level students that are in second semester. So regarding this topic, any question you have, just share your thought on the comment section. If you love this topic, if you understand, if you don't understand, don't worry, just share your thoughts. I'm willing to go back and retreat it numbers of times till you get it. So it's very simple. So now, electric field. Electric field is a region of space where a body feels an electric force. Electric field is a region of space where a body feels an electric force. What do I mean by this? For you to understand this, you need to know two things. You need to do what? You need to know two things. There is two types of charges now, which is positive and negative charge. So the two types of charge we have is positive and negative charge. Let's represent it like this. This positive charge and this negative charge. So for positive charge, it always have line of force, and the line of force always moves what? Outward. So this is the line of force of positive charge. There's always line of force, always moves outward. But for negative charge, the line of force always moves inward. Line of force always move inward. So now, this line of force now, they are region of space. You get what I'm saying? So if you put any body here, or if any object comes within this region of line of force, it will feel what? An electric force. So this region of space like this region of space, this region of space like this, is what we regards to as what? Electric field. So for the negative charge, what is the electric field? This region of space like this. This region of space. Yeah. This is the what? Electric field. As simple. You don't need to cram this. You get. I've told you that for positive charge, this positive charge. The line of force, you get what I'm saying, is always outward. So it has line of force, always outward. So the line of force is always outward. And for negative charge, this negative charge, the line of force is always inward. So the electric field, the line of force is always what? Inward. So now, what is now the electric field around this charge body? The electric field is this region. This region. This is the electric field. And if you put anybody here, if you put an object here, sure you get, the object will feel the impact of this field. So this region whereby an object will feel impact of this force is what we call what? Electric field. If you put the object here, it will not feel the impact of the force, because for this single positive charge, this is where the line of force, this is where the line of force reach. So you get, the line of force did not exceed this location. So that is, this is where the electric field is. And for this negative charge now, you should know where the electric field is within the region of the line of force. So this is where the electric field is. So as simple as that. So you should just know electric field is the what? A region of space. So this is region of space where a body, this is the, feels an electric force. So for positive charge, the line of force is always what? Outward. And if you put a body near the region of the positive charge, the body will feel an electric force. So that region of space within the positive charge where the body can feel an electric force is what we call what? Electric field. So this is the region of space. This is the region of space where the body can feel electric force. But this region of space, the body cannot feel electric force. So for this place now, this is the region of space where the body can feel electric force. As simple as that. Now, the second part is that, the illustration I gave you is for positive charge, the electric field moves what? A line of force moves what? Outwardly. And this region of space around this positive charge is the electric field. This region of space is the electric field. So you get what I'm saying? So that's what I told you. And I did the same thing for negative charge. This is the line of force. This is the line of force. And the region of space around it. This is the region of space around it. It's the what? Electric field, where the body can feel electric force. So now, electric field can also be produced. This by single charge. Shey you get what I'm saying? Can be produced by multiple charge. So there can be up to 3 charge now. You get what I'm saying? Positive, positive, positive. So they can produce what? Electric field. You just see that. So it can be produced by multiple charge. Positive. So it will just be moving outwardly. So they can be produced by multiple charge. So electric field can be produced by what? Multiple charge. So all this region of space around this charge is where the body is the what? Electric field, and it's where the body can what? Feel the impact of the force. You get what I'm saying? So that's just it. So electric field could be produced by what? A single charge. A single charge. And it could be produced by what? Multiple charge. That is 1, 2, 3. There are multiple charge. It is more than one. So, and same thing as that negative. So for negative, will be produced by multiple charge. So it will just go like this. This is multiple charge. No, negative moves inward. So the line of force move inward. So can be produced by what? Multiple charge. They can be produced by multiple. So that's that for that. Now by formula, you get what I'm saying? By formula, the formula to calculate what electric field is denoted by E, and the formula to calculate it is F over Q. So this is the formula to calculate the electric field. You get? So this is the formula to calculate it. And it is the force that is required to move a charge. Now, that is what will determine this electric field strength. Let me show you an illustration. Positive charge moving outward, 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 sorry, outward, outward. Yes. So for this positive charge now, shey you get what I'm saying? This is the line of force. So, uh, and this, let me just put Q. This a body. Shey you get? So the force, the extent of force, this line of force uses to to push this charge body. Shey you get what I'm saying? The extent of force, this line of force around this charge body used to push this body here is what will determine the intensity or the extent of the what? Electric field. So if you want to calculate the electric field of this charge, that is the power is using to push this charge here. So if you want to calculate it, the formula is E equals to force over Q. So that's the formula to calculate it. Now, recall this formula 1. Now, recall that F, if you remember my Coulomb's law, you recall that F equals to KQ1 Q2 over R square. Shey you get what I'm saying? So F equals to KQ1 Q2 over R square. So this is the formula for F, if you remember. Now, can't we do this? We can put this force into this formula. So let's do it. Put F equals to KQ1 Q2 over R square into equation 1. So doing that, I think we have E equals to, now instead of F now we'll put this formula because F is still same thing as this. So instead of F we are putting this KQ1 Q2 over R square. So this for F. So instead of putting this F now in this formula, we have represent all the F by this. So over, that is divided by q. So instead of, let's just say divided by this q. So now let's solve mathematically. We have something E equals to kq1 q2 over r square. Now if you are dividing two if you are dividing fraction or something in mathematics, like if you are to divide these two fractions in mathematics 2, shey you get what I'm saying? This is how to do it. You change the division sign to multiplication. Shey you get what I'm saying? And just remember that this is all over 1, there's a visible one here, but 2 divided by 1 is still 2, but there's a visible one here. So after you have done 2 times 3 and you have changed the division to multiplication, there's an effect that will happen. So you have to what? Put this upside down, change it upside down. So this 1 will come up and this 2 will come down. Then you can multiply. So that's how to divide what? Two fractions. So we'll be doing the same thing here. So now that is, we change the division sign to times. Remember this all over 1. Then bring this one up. Bring it. So let me put it 1 over q1. So now, what are we to do? Just divide this. Q1 divided by Q1. Check out what I'm saying. So your formula is now E equals to KQ over R square. KQ2 over R square. So you can call this KQ1, KQ2, depending on what they are giving you as your what question. So therefore, our final formula for electric field is equals to K. Let's just represent this Q with capital letter Q over R square. So now that's the equation 2. So please take note of these two formula. It is very important. It is very important. So now for electric field, the unit for electric field is Newton per coulomb. This N per C is Newton per coulomb. You know your force. F is force. Let me just write. This is your electric field. And this is the unit. Force is Newton. I believe we should all know that. Our Q represents our charge, and the unit is coulomb, which is C. So that's all. So this your K is a constant. K is a constant, and the constant is 8.999 times 10 raised power 9 Newton meter square per coulomb square. So, and that's all. So take note of this. We'll be using it in calculations. So now guys, the first question to take under electric field. So this is the first question we'll be taking as example. Now this is the question. What is the magnitude of electric field E at a point 2.0 meter from a point charge Q? So we asked to find the electric field from this point charge Q, that's in which the distance is 2 meters. So we have to calculate the electric field. It is very simple. The first thing to do is to take down your parameters. What were you given? So solution. So now we're asked to find our E. We're given our distance. Let's represent the distance with R. So the distance is 2.0 meter and the charge is Q, which is 4.0 MC. So now, just check from these parameters you are given, which is the most suitable formula to use. Is it this? No, we have two formulas that I gave, that I derived. E equals to F over Q, or E equals to KQ over R square. So which one are we to use? Let's compare. We're given E. Okay, this one. Were we given force? No. We're given Q. Okay. So this place, we're not giving E and we're not giving F, we're only giving Q. What about this place? Well, we are asked to look for E, so E. K is a constant. We already know K. We're giving Q and we're giving R. But this place now, we're asked to look for E. We're not giving F. We only know our Q. So which one is the most suitable formula? This one is the most suitable formula. Because most of what we were given, this formula has it. So therefore, we'll be using the second formula. So therefore, E equals to KQ over R squared. That's the formula we'll be using because this formula carries all the parameters we were given. Now, recall, I told you something last time that in our first topic, electrostatic, I told you something that this N represents is nano and it stands for 10 raised power what minus 9. Please don't forget this. So that is, if you have to express this Q properly to become 4.0 times, so because we have already know this N to be 10 raised power 9, anywhere you see N, you put 10 raised power 9, 10 raised power minus 9, so coulomb. So this is our what? Our Q. So now, let's solve. So therefore, our E will now become, I believe we already know our K, it's a constant, it's 8.99 times 10 raised power what? Times 10 raised power 9 times. Our K, okay, we are given, it is 4.0 times 10 raised power minus 9. And our R is 2. There is square in the formula, so we have to square it. So therefore, our E will now become, so now let's multiply everything here. You can do that in your calculator. So if you do that, if you multiply everything here in your calculator, 35.96, 2 square is 4. So therefore our final answer will be Newton per